All right, welcome to, I guess, differential equations. We're doing final exam review here. So one of the first problems I'd like to take the chance to do here is mixing problems, because most students fear these. And I understand I feared them too when I was taking this class. So why don't we see if we can dispel some confusion about these. All right. So we pretty much have the same initial condition. You're only going to get one of these, by the way. I'm not picking out all three of them for you because they take a long time. So one, okay, I'm picking my favorite one and going with that. So each case, right, we have a tank. The capacity is 1,000 gallons. It's only half filled, 500 gallons of brine in it, okay? Let's go with drawing here. So here's the capacity. You got to put this in here because problem number C has it overfill. Okay, other than that, it's not going to matter. You have 500 gallons of brine in here, 50 pounds of salt. Okay, at time zero, the brine containing 5 pounds of salt per gallon allowed to enter the tank at 5 gallons per minute, 10 gallons per minute. Okay, solution is mixed. That's always, even if it doesn't say it, that's kind of an assumption that we have to deal with here. Okay, otherwise, you have a function, you have a density of salt that's going to be dependent on an x and a y and a t for time, and that's going to be a partial differential equation because you're going to have x's and y, maybe even z's if it's deep, right? So we're going to have concentration depending on the location of where you're looking at the river. We're not worried about that. We're just saying it's uniform, so it's a ordinary differential equations. Okay, solution is mixed. We are allowed to drain at the same rate. So it's coming in 10 gallons per minute, it's leaving 10 gallons a minute. How much salt is in it? Well, we know how much salt's coming in. We don't know how much salt's going out. We're at a function to determine the amount of salt in the tank at an arbitrary time. All right. So what we're going to do with this problem, okay, is we're going to set this up, okay? We're going to have our salt. Actually, what I'm going to do is I'm going to write down some givens before we start here. All right. So what do we have? We have rate in, right? That's 10 gallons per minute. Okay, rate out, also 10 gallons per minute. Okay, so we don't have to worry about a changing volume, right? The amount of brine, the amount of fluid that's in that tank is going to stay at that 500 gallons because you got the same amount coming in as going out. Okay, the concentration in, well, that's going to be, what do we say? We have 5 pounds of salt per gallon. And then the concentration out, well, that's going to be a little harder, right? We don't know how much salt's in the whole thing, but we do know that's going to be over 500 because this is initial volume, right? The initial volume, and it's constant. So the initial volume is the same volume that you're going to have throughout. It's 500 gallons. Okay, and how about the the starting amount of salt? Right, and that was 50 pounds. Okay, I promise I didn't get this out of a textbook. Okay, I lied. Of course I got out of the textbook. Okay, these are actually problems are easy enough that if I didn't get out of a textbook, like it's still not going to matter. Okay, the numbers might turn out to be a little weirder, but that's okay. Okay, so we have some stuff, right? We have our system. So what we're going to say here is we're going to say that the change in salt, okay, is equal to the rate in, right, times the concentration in, okay, minus the rate out times the concentration out. Okay, so this is going to be rate in is going to be, what was this? This was 10 gallons per minute. That's how much it was flowing in for. The concentration in, this was 5 pounds per gallon. So unit wise, right, the gallons are going to change. So we're ending up with 50 gallons, oh no, 50 pounds per minute. Okay, and that's the rate coming in. So we're getting in 50 pounds per minute. Okay, minus, okay, our rate out, that was still 10 gallons per minute, right? That's okay. And then our concentration is Q pounds, right? Because we don't have much salts in the tank, divided by how much, there's like 500 gallons in here, right? 500 gallons. So we still get to cancel our gallons, and we end up with minus 10 over 500, 10 over 500 Q, and this is still going to be in pounds per minute, okay? And this is equal to my delta Q. Okay? Now, when we take our limit, okay, we're going to have Q prime, right, 50Q. This is equal to 50 minus, I'm going to go ahead and say this is 1 over 50Q. Normally, right, if I was going to write this problem, I might change it a little bit so there weren't quite so many 50s floating around, because that's going to get a little confusing, and you'll see why we get there. But, not too much of a problem. Okay, so we end up with Q tick plus 1 over 50Q is equal to 50. You could probably solve this with separable, because you could just factor out a 1 over 50 here, pull the 150 out in front, take whatever's left, divide it under, and then you'd have a Q prime over a Q, you'd have a logarithm, it'd be fine. Okay, but I usually solve these problems with integration factors, so that's what we're doing. Okay. So integration factor. Right, this is e to the, what's here? Okay, notice it's plus, so it's 1 over 50 and dt. So this is e to the 1/50th t, right? We're going to multiply this integration factor by everything, okay? So it doesn't always turn into like there's not always a logarithm up here, right? So be careful about that. Just, follow this through. Don't try to force it, okay? Whatever happens with it happens. Okay, so here we have e to the 1 over 50 t times q tick plus 1 over 50 e to the 1 over 50 t times q is equal to 50 e to the 1 over 50 t. All right, now check. Okay, check this. All right, so is this really, if I took this derivative implicitly of q and t, right, what would that look like? Well, it would look like the derivative of the first, this time, times the second, plus the first, q, times the derivative of the second, which would be this thing, okay? And that is equal to 50 e to the 1 over 50 t. Okay. So we're going to integrate both sides here. Oops, t dt. Okay, we're just going to integrate both sides. It's indefinite integral, so we're going to need a constant. So this is the integral of a derivative. So boom, there we go. Okay, and this is equal to 50. And you got to be a little careful here, because this is going to be like 1 over 50 e to the 1 over 50 t. Okay, if I took this derivative, this would cancel with this, and then we'd be all set. Okay, plus c. Okay, so 50 over 1 over 50, that is 2,500, isn't it? E to the 1 over 50 t plus c, that is equal to, we move up this a little. This is q e to the 1 over 50 t. Okay, so you have to be a little careful about the arithmetic in here, but overall it's not quite so bad. Okay. Let's go ahead and isolate q. So what we're going to do is we're going to multiply both sides by e to the negative 1 over 50 t, and then we'll go with that. So that's going to be q is equal to, well, e to the 1 over 50 t, e to the negative 1 over 50 t, that's just going to be 2,500, right? Plus c e to the negative 1 over 50 t. All right. Now, we're not quite done yet. Remember that first sentence of the problem? This is very typical differential equations. The first sentence is your initial condition, right? So at time equals 0, right, we knew that there was 50 pounds of salt in the tank, right? 50 pounds of salt is in the tank at time equals 0. Okay, so there we go. All right. So if I go ahead and set t equal to 0, we get 250 or 2,500 rather plus c. This whole business here is 1. Okay, and that is equal to 50 over here. So subtract 2,500 from both sides, subtract 2,500 from both sides, we get negative 2,450 is equal to C, and Q is equal to 2,500 minus 2,450 e to the negative 1 over 50t. All right, and now there you have it. That's our function. I didn't even ask a follow-up. Okay, I might in t equals 10 or something, but for the most part, final exam, it's like how much you already have to do. So trying to keep it short, trying to keep time at a minimum here. Okay, there's already a lot of hard problems, a lot of long problems to do. All right, I'm going to go ahead and do part B here. Okay, give me a moment, I'm going to get a drink. All right, so here's what we have. Part B. Let's take a look. Okay, a tank with a capacity of 1,000 gallons initially contains 500 gallons, brine containing 50 pounds of salt. Time equals 0, brine containing 50 pounds of salt is allowed to enter the tank at 10 gallons per minute, but it's mixed and allowed to drain at 12 gallons per minute. So it's coming in at 10, it's leaving at 12. So eventually this tank is going to be empty, okay, because we're losing 2 gallons per minute, aren't we? So we have to write a function and go ahead and sort the rest of that out, okay? So let's make a couple of notes. Our volume, right, is losing 2 gallons per minute. So our volume expression should be something like 500 minus 2t, okay? And then we have pretty much the same setup before, right? We could say initial volume if we wanted to, although that doesn't really come into the problem. Well, it does here, right? His initial volume is 500. Sometimes, if you don't know what you're doing, writing down a bunch of numbers that you're given will help, because you're going to stir this stuff up and make alphabet soup. But sometimes it helps just to kind of like you're thinking about it as you're writing it out. So yes, you are technically stalling, but you're doing it in a productive way. Okay, at time equals 0. Q is equal to 50, right? And we also have our rate in, which was 10 gallons per minute. Our concentration in, right? This was 5 gallons, or 5 pounds rather, per gallon. Our rate out, this was 12 gallons per minute, right? And our concentration out, well, that's Q, because we don't know how much salt's in there, and that's telling us how much salt is in there. And then, what did I do in the first problem? I divided by the volume. What's the volume in this case? Well, the volume is 500 minus 2t, all right? So, excuse me, it's important to set this stuff up so that, you don't have to do necessarily this particular step, but it is kind of important to lay out what's going on here. Okay, so we have rate in, right, times concentration in, minus rate out, okay, times your concentration out. All right, so let's go ahead and sort that out. So we have rate in, that's 10, right, and that was 10 gallons per minute. Okay, our concentration in, this was 5 pounds per gallon. Okay, so we have gallons cancel, we have pounds per minute, minus what's our rate out? Our rate out is 12 gallons per minute, right? And our concentration, well, we have Q pounds, right? And then divided by the whole volume. Well, the volume, right, is 500 minus 2t gallons. Pounds per gallon, pounds per gallon. So again, the gallons cancel, so we have pounds per minute, okay? So let's see here, we have a dq, right, is equal to 5 times 10, 50 minus And then here we have 12 over 500 minus 2t times q. I'll bet we could simplify that just a little bit, couldn't we? The semicolon. So we have dq is equal to 50 minus, right, this is 2 times 6, right? So this is going to be 6q over 250 minus t. Okay. And then we're just going to swing this through and do integration factors. Have at it. Okay. So here's my dq plus 6 over 250 minus t times q, right? We add. And that is equal to 50. Okay. Now I'm going to warn you, there's a lot of signs here, and I was a little cavalier when I did this problem to keep track of them all. So you might want to be just a little bit extra careful as you're going through this to make sure that you are tracking your signs and making sure your U's and your DU's have the right sign in it, SITN sign, not SINE, so that this works out for us. Okay, so I'm just going to warn us a little bit. Be careful. This is a lot of pitfalls that you could accidentally fall into and have a problem with. Right? So here we go. So my integration factor, right, this is e to the 6 over 250 minus t dt. Go ahead and integrate this. This is e to the integral 6 ln 250 minus t, right? But when I take my u, right, u is 250 minus t, du is really -1, so we need a negative in here. Okay, so that's going to be e, oops, no more integral, we integrated, sorry about that. So this is e to the -6 ln 250 minus t. This was the most missed thing. This is the biggest mistake people made on this problem. Okay, this is 250 minus t to the -6. And to this day, I have to do it this way. Otherwise, I'll make the same mistake you guys do. And it's just to say e to the, this thing, it's ln, and you'll just leave that -6 in there. It'll be a -6 ln, or -6 ln, or -6 over. It's not. Okay, you got to move this exponent to its proper spot. Okay, so this is equal to 250 minus t to the -6. Okay, be real careful about this. That is the biggest problem that everybody made on their quiz when we had this problem, a problem like this. Okay, so just be ultra careful about that. All right, multiplying through. So we have 250 minus t to the -6. This is q tick plus 6. This is going to be a -1 too, right? So this is 250 minus t to the -7. Okay, q is equal to 50. We have 250 minus t to the -6. All right, so we take our derivative here. That's going to be 250 minus t to the -6 times q. So this was an implicit product rule here. And this is just equal to 250 minus t to the -6. Can I put these in together? Absolutely not, because this, right, this exponent, first off, it's on the bottom. And secondly, this is not a linear type of a thing here. So this 50 is not going in without me multiplying this all the way out, right? I guess we could do, binomial distribution and do that. I would rather not. Okay, even though you can, it's like, no, that's not going to happen. It's not helping. Okay, integrate both sides. 250 minus t to the -6q, right? That is equal to integral. I put the 50 outside here, that doesn't really matter. 250 minus t to the -6. All right, so this is going to be 250 minus t to the -6q. Actually, before I take that derivative, right, or when I take this derivative, right, derivative of the first, well, derivative of q prime times the second, plus, and I take this derivative, isn't this going to be negative 6, 250 minus t to the negative 7 times negative 1, so that'll change that to a positive, because it's a chain rule. So just double check to make sure that this, if you take the derivative of this, you actually get this thing back, okay? So you will, but if you're doubting it for even a moment, even a second, like, wow, that's like magic. It's not magic, check, okay? We're multiplied by integration factor to force the issue on us, okay? A little bit of magic, but make sure it's not magic the way, when it works, okay, that's not proof. It's magic on how we figured it out. But make sure you apply your product when we actually get this thing, all right? And that is equal to 50, and now we're going to integrate this. So it's 250 minus t to the negative 5, right? Divided by negative 5. But really, if there was a u here, right? If we had a u is equal to 250 minus t, du would be negative dt. So that's a positive. But don't answer yet. There's more. Okay, don't forget to say. Otherwise, that's your grade at best. Okay, so here we go. We have 250 minus t, negative 6q is equal to, these cancel, 10. 250 minus t to the negative 5 plus c. Now we're going to go ahead and isolate the q. We're going to multiply 250 minus t raised to the 6th power on both sides. 250 minus t raised to the 6th power. So q is equal to 10, 250, that's a terrible 50, 250 minus t, okay, minus t. 6 minus 5 is 1. I would recommend multiplying this out. I mean, it's not going to hurt anything, but you don't have to. C, 250 minus t raised to the 6th power. Okay? So we have rate at time t equals 0, time equals 0. We had q was equal to what? 50. Okay? So here we have it. We have 50 is equal to 10 times 250, right? T was 0, okay? Plus c, and then here we have 250 minus 0 raised to the 6th power. Okay, so this is 50 is equal to 2500 plus c. I'm not going to do this. I'm just going to call it 250 raised to the 6th power. Okay, subtract both sides, right? Subtract 2500 from both sides. So we end up with negative 2450 is equal to c times 250 raised to the 6th power. So c is equal to negative 2450 over 250 raised to the 6th. So c is a very, very small number, right? Because this is huge. Okay. All right. So what do we have? Because we're not doing a calculation in this case, right? We're just doing this. So we have q is equal to 10 250 minus t, right? Minus 24,550 over 250 raised to the 6th power, 250 minus t raised to the 6th power. Okay, do you see that this is like 250 minus t raised to the 6 over 250 to the 6? Like these are going to kind of cancel each other out a lot. So the numbers are going to be kind of tame once you deal with this. Okay, I guess we could do it this way too. We could say this is 2450, and then here we have 250 minus t over 250 raised to the 6th. That might be a better way to go for you. Okay, if you want to keep like the idea of like how big is this number? Like, well, the t isn't very big. It's not a big number, right? Or I should say it's huge. Well, t is close to 0. This might as well be 1. Okay. When t is when t is like a 0, no, when t is like a big number, like 249, then this is going to be extremely small. Okay, and there's my q. Okay, notice when I come up with the problem, right? It says When will the tank be empty? Well, what happens when T is 250? Right? It's leaking out 2 gallons per minute. We start with 500 gallons. We're losing 2 per minute. So in to the 250th minute, right, 4 hours later, what's going to happen here? I'm not going to have any salt in the tank. Why not? Because there's no water in the tank. There's nothing in the tank. All right. So there you go. All right. Part C. All right. Let's go ahead and have a read. And again, you're going to get the same initial conditions here. Okay, because I wasn't trying to come up with 3 different problems. I figured, well, one problem with different scenarios will probably do it. I might change this around a little bit because again, I don't like quite so many 50s, but you know, the kind of problem is going to be real close to this. I'm going to stay away from problems we have to convert from a concentration back into a pounds. It's like we're not doing English to metric, not doing any of that. Okay. Tank with initial capacity of 1,000 gallons initially contains 500 gallons of brine containing 50 pounds of salt. Tide equals 0. Brine containing 5 pounds of salt per gallon is allowed to enter the tank at 10 gallons a minute. Solution is mixed and is allowed to drain at 8 gallons a minute. So it's coming in at 10, only leaving at 8. So this is every toddler's favorite experiment, right? Stop up the sink, still drains a little bit, but eventually there's going to be a mess. Okay, so rate of function, right, for Q, when will the tank overflow? And I tried to put like, when will the tank be empty? When will the tank overflow? So you have like one additional hint that the volume is going to be changing. Notice we didn't change anything here. Okay, so I didn't say anything about the tank emptying or overflowing. But here, since the volume is changing, I want to clue you in like, hey, the volume is changing, so that you don't make the mistake of not having a different volume. Okay, so same thing, right? We're going to have volume. Well, that's 500, but we're adding, right, 2 gallons a minute. Okay, so rate in is 10 gallons, rate out 8 gallon, conc in is 5 pounds per minute, conc out was Q over my volume, 500 plus 2T, pounds per gallon, okay? Pounds per gallon. Oh, conc is, this should be gallon here, sorry about that. 10 gallons per minute, 8 gallons per minute, okay? So we go through, we have our delta Q, right? So we're going to have rate in times concentration in, okay, minus our rate out, concentration out, okay? And then we're just going to start filling some of this stuff in. Our rate in, right, that's 10. Concentrate, oh, we'll go ahead and do it this way. Rate in is 10 gallons per minute. Okay, concentration in is 5 pounds per gallon. So again, the gallons disappear. Minus our rate out. Well, how fast is this leaking out? So it's only leaking out at 10 gallons per minute, right? But the concentration is Q pounds over the volume, but the volume is changing. So that's 500 plus 2T gallons. Gallons cancel. We have pounds per minute, okay? So let's go ahead. We have a dq is equal to 5 times 10, 50, minus, we have an 8q over 500 plus 2t. Well, that's going to be the same as, right? dq equals 50 minus, so minus, okay? We have a 2 times, right? 8 is 2 times 4. So we have a 4q over 250 plus t. Okay, so swing this over to the other side. dq, okay, plus 4 over 250 plus t times q is equal to 50. Right? Integration factor e to the 4 over 250 plus t dt. So that's going to be e to the 4 ln 250 plus t. This one's so much nicer. Look at this. There's no negatives we got to track and everything. It's nice. We still got to keep track of this though, right? This is still e to the ln 250 plus t to the 4th power. Now we can use our logarithm rule. We can go ahead and say our integration factor is 250 plus t raised to the 4th. Okay, great. So let's go ahead and multiply everybody by this thing. Okay. Notice one of these is going to cancel, right? This is going to cancel with this guy here. So we're only going to have 3 of them. So here we have it. We have 250 plus t raised to the 4th power times q tick plus 4 250 plus t raised to the 3rd power, right? 4 minus 1 is 3. Q is equal to 50, 250 plus t raised to the 4th power. Okay. And then we'll go ahead and check. So we have our derivative of 250 plus t raised to the 4th times q. Right? And if you were to take this derivative, right, what would you have? Well, you'd have 4 times 250 plus t raised to the 3rd power times q, plus this thing by itself, right? And then q's turn to take a derivative. So double check your product rule, make sure it works. 50, 250 plus t raised to the 4th power. Okay, take the integral of both sides. That's just a 4. It shouldn't be a negative or anything like that. It's q. Okay, and that's a derivative. Okay, and then we have integral of this side, which is going to be 50. We'll put that here. 250 plus t raised to the 4th. T. All right, so this is 250 plus t raised to the 4th power q, right? Just the integral of a derivative. And that was equal to 50. And then here we have it, right? 250 plus t raised to the 5th power all over 5 plus c. Okay. So here we have it. We have 250 plus t raised to the 4th q is equal to 10. 250 plus t raised to the 5th plus c. Divide both sides, right? By 1, or multiply by 250 plus t raised to the 4th power. So what happens? We have 10, 250 plus t, because we have 5 here, 4 here. Okay, plus c, and then we have 250 plus t raised to the negative 4th, and this is equal to q. Okay, when t was equal to 0, q was equal to 50. Okay. So let's go ahead and sort that out. So we have 50 is equal to 10 times 250 plus c, and we have 250 to the negative 4th power. Okay. So this is 50 is equal to 2500. Okay. Plus c over 250 raised to the 4th power. Subtract 2500 from both sides, so we have negative 2450 is equal to c over 250 to the 4th here. This is 4. Multiply through, we get c is equal to negative 2450 times 250 raised to the 4th power. I'm sure that's a delightful number. I don't really care what it is. Okay. But q is now equal to, right, just to write the function down by itself, we have 10, 250 plus t, okay, minus 2450, 250 raised to the 4th power over 250 plus t raised to the 4th power, I believe. Yep. All right, and there is my function. but I didn't multiply this. It doesn't matter. Okay, when will it overflow? Well, right, we started with 500 gallons was in the tank at the beginning. We were adding 2 gallons per minute, and we have an additional 500 gallons to fill. So 250 minutes. So time to finish the tank is 250 minutes. So we can plug that in here, divide, everything will work out. Okay. So that's how much salt will be in the tank at the end of our, what is that, about 4 hours. Okay. So that is how you do a mixing problem. I hope you got some insight into doing these. I hope they don't look quite as difficult. Okay. You're not doing all 3. All right. You're just doing 1. But try to be careful about watch your signs. Make sure your value at the end looks like it makes sense. Okay. It's not always a logarithm. Sometimes it isn't. Okay, you have the exponential versus the logarithm. So just a couple of things to be careful of. Make sure you move that coefficient to the exponent position before you apply your e to the ln. Okay, biggest mistake I saw. And good luck with this one. Okay, I'm going to post this as a paper as well, so you don't have to go through the whole video. All right, but thank you. Good luck.